If we're talking about similar triangles are two triangles that are the same shape but are different sizes. So congruent triangles are two triangles that are the same shape and the same size, so they're identical, whereas similar triangles are two triangles that are the same shape but are different sizes. So one will be an enlargement or a reduction of the other. With similar triangles, however, we know that the sides of the triangles are in proportion to each other and that the three angles in the corresponding triangles will be the same. And that's what gives us similar triangles. Therefore, we can either prove similar triangles in order to work out the length of a side, because we know that the sides will be in proportion to each other if the two triangles are similar. Alternatively, if we're given that the sides are in proportion, we would be able to determine or calculate the value of a length, or we'd be able to conclude that the triangles are similar. If we look at our first question, it says, determine the lengths of the unknown sides given that triangle ABC is similar to triangle PQR. Now, if you look here, you can notice that the sign for similar is three little lines going down instead of three little lines going across like it is for congruency. If we're determining the length of the unknown sides, we need to know what I like to call Frogface. All right? So, what does Frogface mean? What I'm going to do is I'm going to rewrite my triangle. So I have triangle ABC and I have triangle PQR. If I look at triangle ABC and triangle PQR, what I can now do is I can do my frog face. What does that mean? Well, I have two eyes and I have a mouth. So with similar triangles, the sides are in proportion to each other. All right, so it's left eye over left eye, right eye over right eye, mouth over mouth. Now, obviously, we're not going to talk about it as left eye, right eye, mouth, and mouth. However, it just helps us to identify what we're working with. So, if I were to take the left eye of both frogs or triangles, I would have AB over PQ. Then I would take the right eye of both of the triangles or the frogs. So there I have right eye. So that will be equal to BC over QR, which would therefore be equal to the mouth over the mouth. So that's side AC over side PR. So now I'm able to put my sides in the correct order, my proportion in the correct order based on my triangles. So if I were to highlight the sides, I have AB over PQ. So what I've done is I've identified the corresponding sides in the two triangles. Now, why is that important? Well, because sometimes the triangles, it's not going to be as visible to you which sides are in proportion to each other or which are the corresponding sides, because sometimes your triangles will be flipped, will be spun around. Sometimes you have two triangles within other triangles or circles or whatever the case might be. Then I have BC over QR. And my last side is AC over PR. All right, now looking at that, I can now see very clearly which of those sides I have both lengths for. So if I'm just talking about my diagram, I have green sides, blue sides, and I have red sides. Now, if I look at my diagram, I have the two green sides have both pieces of information filled in. So the two green sides, I have a 30 and I have a 60. Then my red sides, I'm missing the X. So I will now be able to use my green sides in order to calculate the missing length of my red side. Then I can use the green side again to calculate the length of my missing Y on my blue side. Okay, so because these two triangles are similar, it means that the sides are in proportion, which is why I can equate the sides the way that I am, because the ratio between the sides will be constant or will be the same. So now, if I want to determine the length of the unknown sides, I would be able to say that in my diagram, I have AB over PQ, and that would be equal to, and I'll start with X, AC over PR. All right, now why would I be able to conclude that, or why would I be able to state that? Because I have similar triangles. Okay, so because I have similar triangles, it means that the sides are in proportion. Also, what Frogface helps us to do is it helps us to keep the triangles in the correct order. What do I mean? Triangle ABC, you can see, is smaller than triangle PQR. So that means that at the top, you can see I've kept the small triangle at the top and I've kept the big triangle at the bottom, because we can't swap the orders around. All right? We could have all the big triangle over all the small triangle, but you can't have small triangle over big triangle over small triangle. So I wouldn't be able to say AB over PQ is equal to QR over BC, for example. So I have to keep the small triangle at the top, the big triangle at the bottom. All right, so now that I've concluded that AB over PQ is equal to AC over PR, now I can fill in my information. So AB's length is 30, and that is over PQ's length, which is 60, which is equal to AC's length, which is 25, over PR's length, which is X. Now that I have these two in proportion, what I can do is I can take the 60 from the bottom and I can multiply it with the 25 at the top. And I can take the X of the bottom of the right-hand fraction and I can multiply it with the 30 at the top of the second fraction. All right, so now I have 30 times X, which is 30X, equal to 25 times 60, which is 1,500. But I want the X by itself. So what I'm going to do is I'm going to divide both sides by 30 to get rid of the 30. So therefore, I'll have X equal to 1,500 divided by 30, which is 50. So I can take that 50 and I can put it onto my diagram in place of my X, because now I would have that 50. Which means that now what I've done is I've created another set of corresponding sides in my triangle with both values filled in. So I'm still missing the Y on my blue line, but I would then be able to use the fraction that I used originally of my green line, or I could now use my red line as my second fraction set. So if I use my first set again, so I want to use my first line, which is AB over PQ, equal to, and now I'm going to calculate Y, which is BC over QR. Now the reason I'm keeping the same fraction is because if you've made a mistake in your previous calculation, now you're just going to be carrying your mistake through. Whereas if you just use the original, then you stand more of a chance of getting it correct the second time as well. All right, but in order to state that these sides are in proportion to each other, we have to say why we're saying that, and the reason we're saying that is because of similar triangles. All right, so AB's length is 30 over PQ's length, which is 60, equal to BC, which is Y, over QR, which is 80. So I'm going to take the 60 and I'm going to cross multiply it and multiply it with the Y. And I'm going to take the 80 and I'm going to multiply it with the top, which is the 30. So now if I say 30 times 80 or 80 times 30, I get an answer of 2,400 equal to 60 times Y, which is 60Y. Now I want to get the Y by itself, so that means that I'm going to divide both of the sides by 60. So 2,400 divided by 60 is 40, equal to 60y divided by 60, which is Y. So now I have Y's value being 40, and I would be able to then put Y's value of 40 onto the diagram. And you can actually see that our proportion or our increased factor would be a factor of 2. That triangle ABC is increased by a factor of 2 because my 30 to my 60 are multiplied by 2. My 40 to my 80 are multiplied by 2. And my 25 to my 50 are multiplied by 2. Prove that triangle ABC is similar to triangle ADE and then determine the value of X. So now what we're going to do is we're going to start by proving similarity. Once we've proven that the two triangles are similar to each other, then that means that the sides are in proportion. All right. Now we only have one condition of similarity, and that is angle, angle, angle. So the three angles in the corresponding triangles have to be the same. Now that's different to our congruency, because in congruency we had our four conditions of congruency. So we had side, 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 angle, angle, and right angle, hypotenuse, side. So we have four conditions of congruency, but only one condition of similarity. So with similarity, we have to prove that the three angles in the two corresponding triangles are the same. That's what proves similarity. If we look at our diagram, we have triangle ABC. So if I look at triangle ABC, and I'm just going to color it here, triangle ABC is this big triangle over here. All right, so I have the big triangle, triangle ABC, and we need to prove that that's similar to triangle ADE. And ADE, we can see, is this smaller triangle over there. All right, so I have in my diagram, it's yellow and it's red. So I want to prove similarity. All right, what information have I been given? I've been given these two little triangles, or these two little arrowheads, which tells me that line DE is parallel to line BC. All right, so I'm told that those two sides are parallel to each other because of those little markers. Because they're parallel, it means that I could have my F shape. All right, so if I look over here, I'm coloring it in blue. All right, so there's my F shape. So that would mean that angle D1 will be equal to angle B. Why? Because they're corresponding angles. But I also have an F shape going in this direction, an upside down F shape over here, which would tell me that angle E1 is equal to angle C, and you can see that I've done that now in purple. And then I also have, can you see that both of these triangles, the big triangle and the small triangle, both share the angle A? What does that mean? That means that the angle A is common to both of the triangles. So like in congruency, when we use a common side, in similarity, we can use a common angle because both of those triangles contain the angle A. I'm going to start by saying in triangle ABC and triangle ADE. When we're working with similarity, we need three angles that are the same. Now, that brings me to my next point. When proving similarity, even though you're proving that three angles are the same, you actually only need the information of two of the three angles, because the interior angles of a triangle are supplementary. They equal 180 degrees. So that means that if you have two of those angles in two different triangles being the same, it means that automatically the third angle has to be equal in the two corresponding triangles, because the angles need to total 180 degrees. So if in triangle 1 you have an angle of 100 and you have an angle of 50, then together you have 150 degrees, which means the third angle has to be 30 degrees. If in the second triangle you have an angle of 100 and then you have an angle of 50, then that also means that the third angle has to be 30, because your angles have to total 180 degrees. So for similarity, you only need to prove two of the three angles are equal, because then the third angle will have to be equal because of the interior angles of a triangle. So if I look here, I've got my two triangles, ABC and triangle ADE. So I can start by saying that angle A is equal to angle A. Why is angle A equal to angle A? Because it's a common angle, or because it's common to both triangles. So now I have angle D1 equal to angle B. Now, even though D1 is equal to B and B is equal to D1, the order that I listed is important. Why? I'm not going to say D1 equals B, because D1 is in this small triangle and that's second, which means it needs to stay second. So I'm going to say that angle B is equal to angle D1. So you can see that even though D1 and B, if I'd written it in the opposite order, it still would be accurate to the equation, but I just need to keep my angle order correct. All right, so I have B equal to D1. Why? Because they are corresponding angles. Now remember, whenever you use corresponding angles, co-interior angles, or alternate angles, you have to state your parallel lines. So line DE is parallel to BC. So I could therefore say, and again, E1 is equal to C, yes, but E1 is in the second triangle listed over here. So that means that I'm going to start by saying angle C is equal to angle E1. Now I have two options of what to say. I could say that they are corresponding angles because they are, and DE is parallel to BC. Or I could have just written angles in a triangle because the interior angles of a triangle are supplementary. So now I have three statements, three reasons, so I can conclude that triangle ABC is similar to triangle ADE. What is the condition of similarity? There is only one condition of similarity, and that is angle, angle, angle. Now that I've proven that the two triangles are similar to each other, I can therefore state that the sides are in proportion. Once I've got the sides in proportion, I'm able to calculate or determine any given length or missing length. If I look at this picture here of what I have, I know that I have these two triangles being similar to each other. So I'm going to now be working with determining the length or the value of x. So if I have triangle ABC and triangle ADE, my first step is my frog face. So I have the left eye of each of these triangles. I have the right eye of each of these triangles. So that's going to give me my sides that are in proportion. And then I have the smile of each of these triangles. So I can therefore conclude that the left eye, AB, over the left eye, AD, is equal to the right eye, which is BC, over the right eye, which is DE, which is equal to the mouth, which is AC, over the mouth, which is AE. So I can therefore conclude that all three of those sides, or the corresponding sides, are in proportion because they are similar triangles. Now, if I were to color code that, AB over AD, so that's AB, which is the full length over here, over AD, which is the smaller length. Then I have BC, which is this length over here, over DE, which is this length over here. And then I have the mouth, which is AC, which is this full length over here, over AE, which is the smaller length over here. All right, so I've color coded mine, green, blue, and red. Now, if I'm looking at this information, I am looking for this missing value of x. So actually, I know that length AE is equal to x. So that's what I'm looking for. I'm looking for line AE. Now, I can see that in my diagram, AE is one of my red lines. So I know that I'm going to be working with my red fraction, all right, which will be the AC and the AE. So I'm going to be working with that. And now, if I look at my green and my blue lines in my diagram, then I need to say, are my green lines, do my green lines have all the information filled in? Do my blue lines have all the information filled in? And in this case, both of them have all the information filled in, which means that I could therefore pick either green or blue. So in this case, I think that the easier one to pick would be the blue lines. So I'm going to work with the blue lines. All right, so I'm going to say BC over DE is equal to AC over AE. All right, now based on this, I'm going to now fill in all the information. So what is BC's length? BC is 12. Over what is DE's length? DE is 8. That is equal to AC. Now, if we look at AC, we can see that AC is actually a combination of line AE and line EC, because AC is that full line, all right? So that's the combination of AE and EC. So AE is X and EC is 3, so it's X plus 3. Remember, I can't add X plus 3 to get 3X because they're unlike terms. And that is over line AE, and line AE is X. All right, so now I have my sides in proportion, and I'm going to work the exact same way that I have been working. So I'm going to take the bottom and I'm going to multiply it with the top. But at the top I have a binomial, so I'm just going to put it in brackets. And then I have the X at the bottom, which I'm going to multiply with the 12 at the top. So I have 12 times X, which is 12X, equal to 8 into X plus 3, because it's a binomial at the top. So I have 12X equal to, now this 8 is going to jump into the bracket, so it's going to multiply with the X, and it's going to multiply with the 3. So I'm going to have 8 times X, which is 8X, and 8 times 3, which is 24. Alright, now I'm going to group my like terms, so I'm going to take this 8x across, or I'm just going to subtract 8x from both sides. The 12x stays the same, stays first. The 8x, when it goes across the equal sign, now becomes a negative 8x, and that is equal to 24, because the 24 stays on the right. So now I have 12x minus 8x, which is 4x, equal to 24. And now I want to get that x by itself. So in order to get the x by itself, I'm going to divide both sides by 4. So therefore, x is equal to 6. So I could take that x being 6 and put it onto the diagram. AE and BD are straight lines. Prove that triangle ABC is similar to triangle EDC, and then determine the values of x and y. Alright, so I want to prove that triangle ABC is similar to triangle EDC. Once I have the two triangles being similar, it means that the sides are in proportion. Once I have the sides in proportion, I can then determine the lengths of any unknown. Alright, so let's start by proving that these two triangles are similar. Remember, once I prove similarity, then I'm able to determine any length of any side because the sides will be in proportion. Remember, to prove similarity, I only have one condition of similarity, and that's angle, angle, angle. I need to prove the three angles in the two corresponding triangles are the same. But remember, I don't actually have to prove that all three angles are the same. I only have to prove two of the three angles, because then the third one is automatically equal because of angles in a triangle. So if I look over here, I am given, based on the diagram, based on this representation, I am given that side AB is parallel to side DE. Now, if those two sides are parallel, then that means that I could make my N or my Z shape, which would tell me that angle B is therefore equal to angle D. Now, I could make my Z shape the other way as well, with AB going down AE, or I could see as well that I have angle C1 equal to angle C2, because they are vertically opposite angles. So I have either of those options to work with. Remember, I only need two to make it work. So I'm going to start by proving my similarity. So in triangle ABC and triangle EDC. All right, just remember that the one triangle needs to stay first and the other triangle needs to stay second. So if I'm looking at triangle ABC, what's my angle in ABC? Angle B. So angle B is equal to angle D. Why is angle B equal to angle D? Because of alternate angles. It makes a Z or an N shape. Remember, you have to state your parallel sides. So AB is parallel to DE. Then I have angle C1 equal to angle C2. Why is C1 equal to C2? Because they are vertically opposite angles. And vertically opposite angles are equal. Then I could say that angle A equals angle E because of alternate angles. So angle A is equal to angle E. I could say alternate angles again because that is true. Alternatively, it's my third angle, so I could just say angles in a triangle. So therefore, I have three statements, three reasons, so I can conclude that triangle ABC is similar to triangle EDC. Don't forget to state your condition of similarity, which is angle, angle, angle. Now that I've proven the two triangles similar, I can therefore work out my sides in proportion. So I'm going to do my frog face. So I have triangle ABC and triangle EDC. So that means I have the left eye over the left eye. I have the right eye over the right eye. And I have the mouth over the mouth. So I can say that AB, which is the left eye, over ED, which is the left eye, is equal to BC, which is the right eye, over DC, which is the right eye, which is equal to AC, which is the smile or the mouth, over EC. Why am I stating that those are in proportion? Because of similar triangles. All right, so I have AB over ED. So I have AB over ED or DE, it doesn't matter. Then I have BC over DC. And I have my last set of sides, which is AC over CE or EC. All right, so now I have red, blue, and green again. So based on my colors, red, blue, and green, we can see that the full information or the fraction that will have both the numerator and the denominator as numerical values are my red lines. So I have two red lines with both the values filled in. So that's going to be my starting fraction to calculate the x, which is a green line, and the y, which is a blue line. All right, so my red lines are AC and EC. So I'm going to conclude that AC over EC is equal to, and I could calculate x or y first, but I'm going to do x, which are my green lines, which are AB over ED. All right, so now I'm just going to fill in my information. So AC's length is 5 over EC's length, which is 6. That's equal to AB's length, which is 7, over ED's length, which is x. So now I'm going to take the 6 from the bottom. I'm going to multiply it with the 7 on the top. I'm going to take the x from the bottom and I'm going to multiply it with the 5 at the top. So 5 times x is 5x is equal to 6 times 7, which is, so now to get rid of the 5, I'm going to divide both sides by 5 to isolate the x. So therefore, x is equal to, and 42 over 5 stays 42 over 5. All right, I want to work out the next side or the next missing length. So that means that I'm going to stay with my AC over EC because those are the lines that I had both pieces of information filled in. And that is equal to the y that I'm looking for is my second set of lines, which is BC over DC. All right, so AC's length is 5 over EC's length, which is 6. And that is equal to BC's length, which is y, over DC's length, which is 10. All right, I'm going to take the denominator, the 6, I'm going to multiply it with the numerator. And I'm going to take the denominator of 10 and I'm going to multiply it with the 5 at the top. So 5 times 10 is 50, equal to 6 times y, which is 6y. In order to get the y by itself, I'm going to divide both sides by 6. So therefore, y is equal to 50 divided by 6 is 25 over 3. When we're doing our sums and we get to an answer fractions that kind of don't look right, then we always doubt ourselves and we're like, oh no, I've made a mistake, don't worry about it, because with similarity and the sides being in proportion means that the ratio, the proportion between the two sides, needs to remain constant. The ratio remains constant. So if I just quickly draw your attention to the sides, and I've put the answers that we've just calculated into a ratio, all right, or into proportion. So AB's length is 7, ED we calculated to 42 over 5. BC's length is 25 over 3, DC is 10, AC is 5, EC is 6. If I were to divide on my calculator 7 divided by 42 over 5, I get an answer of 5 over 6. If I were to take 25 over 3 divided by 10, I get an answer of 5 over 6. And the side that I was given originally is 5 over 6. So therefore you can see that they're all in proportion to each other. All right, but how do you determine which sides are similar in a rectangle or a non-triangle shape? If I had A, B, C, D being similar to E, F, G, and H, then using our frog face that we have used, what we're going to do is we're going to do frog face plus a nose. So it would be left eye, right eye, right eye. And then we have our smile, which is the first and the last, but we are going to add a nose. So there's my nose, there's my nose. So you can see that that's my nose. Doesn't really look like a nose, but let's just pretend. So I would be able to say that AB over EF, which is the left eye, would be equal to CD over GH, which is the right eye, will be equal to the smile, which is AD, over EH, which would be equal to the nose, BC over FG. I do hope that this video has helped. Remember, the more you do, the better you'll be.